It has been a hot second since we have made a material atomics video, but we are on a trip around the Southwest right now for the holidays and figured that we would check in to talk a little bit about where we are with the book that we've been writing and with a topic that we've encountered multiple times during our patron chat, which is the nature of energy. We just had this weird realization that we've written this entire book about the material atom where we explain, light, gravity, electricity, electromagnetism, and we mention the word energy, but I don't think that we have a full layout of what we mean when we use the word energy. So maybe we can do a little bit about the book first, and then we can move on to energy.
The book is going to be half historic retrospective about why this problem exists. Why do we even need to have this channel in the first place? Isn't there already a physical conception of the atom? And it turns out there isn't, and it was lost very piecemeal over the years and replaced with a purely mathematic, abstract, schematic version of the subatomic, the atomic landscape. So half the book is checking out how we got here. The rest of it is our own particular solution set, which you've seen us develop at this channel over the past few years. And then we try to make the case for why it matters, which is something we should probably do a little episode about here in the future, because I'd like to hear your thoughts as well. But, like Anastasia said, this word energy has come up multiple times, and after we finished the first draft of the book, I realized we hadn't addressed it head on, and we need to put something in there. When we brought up the idea of energy at our patron chat for the podcast,
which you can join at this link right up here,
we were surprised that people were clinging to a more ethereal idea of energy that couldn't be pinned down. They didn't like, there's this inherent resistance to putting a definition on paper for the word energy, which I thought was sort of bizarre. And I kind of want to just play with why that is. So,
should we lay out the definition?
Yeah, that's what I was going to do, exactly. So we tend to think of energy as meaning some sort of material in motion. Now you could have a potential energy, which means something has the potential to go into motion, or you have, say, elastic tension stored, which is able to be released.
In a spring, let's say.
Yeah.
Or a ball that's sitting at the top of a hill. Like, these are really conventional examples that you learn in, first semester physics.
Or you have a high energy molecule, right, where the chemical bonding stores the energy, which gets into this really abstract, because I'm talking about storing an idea. But what I really mean is just that those bonds, when broken, can elastically release a lot of motion into the system. And so there's lots of applications of energy, potential energy, but it's very difficult to rationalize a meaning for this word outside of material and motion. And even if you look at our fundamental definitions of energy, work, let's say, well, what is work, right? It's applying some effort to something across some distance, right? You're moving stuff. E equals mc squared. Well, m, right, it's referring to some material that is locked inertially in some system, and you're moving it, c squared, you're accelerating it, right? In every case, you're talking about material in motion. But this doesn't seem to sit well with most people that I've talked about this concept with. And why is that?
Well, energy is something that is accounted for and measured. But in a universe of quantum field theory, there aren't objects that are down at the very bottom of nature. I think that everybody kind of accepts this really uncomfortable and yet titillating version of the world where there is a layer of the universe that is incomprehensible to the feeble human mind. And so when you get down to the very basement layer of it, if you are able to move things around with using energy, if you're able to do stuff with this magical quantity that doesn't really have a material basis, it leaves open a little bit of mystery in the universe, is what I think is experiencing.
I think it's about leaving the door open to something.
Because I think that this is the biggest criticism that people have for material atomics without really even knowing that this is their criticism, it's that it's not very magical. This was kind of something that when we started doing this project, I was like, we're never going to be able to sell people on this because there's no spookiness, there's no mystery, there's no oddity, there's no weirdnesses. It's just stuff that moves and acts, and in moving and acting gives rise to all of the things we see. And you can have a little bit of mystery in the complexity of it. You can have a little bit of awe in the way that these things assemble to produce us and this like very weird experience that we're having right now. But it's fundamentally not spooky. And I think that that's a really hard sell for people because why have we had religions for thousands and thousands of years, if not because people really, really need a spooky parameter in their lived experience?
See, I don't think it's necessarily because people are superstitious dum-dums per se.
I didn't say that.
Right, I know, but when you say that they desire spookiness, I feel like it leans towards this idea that people require the superstitious, but I think it's deeper than that because people actually assert that the universe is made out of matter and energy. So it's actually constructed from these motions in some sense. And I feel like our everyday lived experience being a human being is so much about relationships and so much about how we behave. And these are really abstract, multi-order removed concepts from a simple body in motion, right? How you behave yourself, how you cultivate your thoughts and your mindset and your health and your family and all of these things which don't really have, well, let's say physics doesn't really have much purchase on them. Physics being material reality. It's not the best lens to try to understand these principles of the universe, which are very real. And so I think that for most people, they look at physics and they think physics is supposed to be this totalizing science that explains everything, right? No other field has theories of everything on the horizon. And when people think about a theory of everything, an explanation for everything, they think, how could it not include all of these second, third order ripples, these experiences, these behaviors, these abstractions? And in some sense, they do terminate on the physical. But I'm not sure that physics is the proper discipline to examine those, because we end up with something like energy being the spirit that moves things, and it's not really an appropriate place to handle such complicated features.
Interesting. So
Compounded, maybe. Not complicated, but complex and compounded and second, third, fourth order motions, relational motions.
I thought that where you were going to go with that is that because we recognize that matters, so you started off by saying, like, we on our scale live inside of a context where there is matter and there is relation. And so you have an individual and you have the sum total of the social and personal and professional relationships and even, natural relationships that that person has. And so we look at the foundations of the universe and we're like, look, there must be matter and energy together, because energy is the analogy for the relationships of the objects the object of the person in relationship to all of the other objects, right?
Or the relationship of the bodies of the subatomic, landscape with respect to one another.
That's what I'm saying. So, like, we take this perspective. I thought that's where you were trying to go with it.
It's kind of where I'm going. I'm just trying to be, in some sense, I don't want to use the word forgiving, but it's understandable that people recognize material by itself without the relational motions isn't very explanatory for the universe in terms of theories of everything. There's a huge portion that's missing if you just look at the materials. You have to look at the materials in motion and the particulars of their motion with respect to one another, which is where we get hung up on the idea that the universe is made out of energy, out of those relational patterns.
Well, I think that the word energy in a lot of cases is stand-in for prime mover, right? Because I think that the way that a lot of people think about the history of the universe is that there was a time where it was not as differentiated as it is today. Whether you think that it's like a big bounce cosmology or it's a big bang cosmology, or you recognize that the universe is eternal and you look at it in the sense of there being phases of it, where sometimes it becomes more differentiated and then it breaks down and becomes less differentiated, you recognize that there is some foundation, and that foundation can become very, very still and then needs to develop into something complex again. Like, I think that complexity and motion are kind of related to one another. And so I can imagine periods of the universe being very, very still with very little motion, and then this gradual coming together and nucleation of gravity-based and chemistry-based and electromagnetic-based interactions. And so the thing...
Well, that's how you get a human being, right?
I mean, over spans,
Sometimes that becomes a human being. Sometimes it becomes a star.
Yeah,
Sometimes
exactly.
it just stays a cloud of very simple S-shell hydrogens.
And the question that people, when people say that energy is the foundation of everything, I think that what they're saying is that it's the movement that allows these things to happen, because you can have the matter, and if it's still, if it has no movement whatsoever, then you'll never get to a place where you have a star, a planet, a person. You'll always remain in this undifferentiated soup that's just kind of like...
And what's fascinating about studying energy or thermodynamics is that you can come to appreciate how simple dissipative actions, so really rolling downhill, things crashing into each other, tugging on each other, and trying to relax, can actually lead to the production of incredibly organized structures, whether it's a crystal or a human being. They're all essentially dissipative processes that are being undergone in order to result in those particular organizations with tons of chaos all around them. And so I think by looking at energetics, understanding that you're talking about material motion relationally, right? And you're talking about how do you get complexity, it becomes a really interesting science in and of itself.
And I think that people really resist the idea that energy can be simplified to matter in motion, because it then leaves them with the question of like, well, what started the motion? And then you have kind of an axiomatic thing where you're like, well, motion is eternal. And I think that's unsatisfying for people too. I really think that people want beginnings. I think that people want there to be a start, because there's no other way to conceive of the universe.
There's no other way to conceive of your own life other than having a beginning and end.
Any life.
Any life, right? Life, let's say, has a beginning and end, a life form anyways. And so I think that in some sense, that's a psychological holdover from the way that we experience existence, period, as human beings.
But I think that a rock has a beginning and an end.
Of course.
I think all things have beginnings and ends.
All things, all bodies, yeah, but maybe not the set of all bodies. I mean, I don't know if we want to do a Big Bang conversation right now.
No, but I think that's where the great debate about the nature of energy comes from and what it is, because I think that people recognize inherently that when you begin to consider the set of all bodies, that you really quickly run into the question of where does the motion come from? Because even if you say that energy is matter in motion, or matter that has the potential...
I'd use the word material.
Material in motion, or material that has the potential to be in motion, then you haven't solved the question, because then it's like, okay, well, where does the motion come from? And then you have all of the other problems of like, okay, well, was there ever a time of stillness? Is there always a time of motion? There's this idea of the heat death of the universe, that, everything will grow farther and farther apart and grow more and more still, and that everything just kind of dims and becomes cold. And so if there was a time before motion? Does that mean that we head to a time after motion? Is there an arc of the universe from which new motion has to emerge? Like, it doesn't resolve people's curiosities, because I think that it leaves them with more questions they had when they started in a way that's not putting a period on the end of the sentence. It's like a semicolon or something in a very long run-on paragraph of physics.
I mean, I have a lot of thoughts about this Big Bang cosmology and eternity and all of these things, but I'm not sure that they can be contained within this conversation.
I think that it's impossible to talk about energy without talking about the history of energy and the history of the universe and the beginning of things, because that's always the question. Like, energy was supposed to be there in Big Bang cosmology before everything else, right? It's the potential energy for the singularity to explode.
Potential.
Yeah. And so, like, energy comes first, and there's this location that contains the entire known universe that's supposed to, like, unfold.
But if, under that definition set, all of that material was in motion. It was just motion stored in different, tensions.
Well, so it's not in motion, by definition. Something that's under tension is not in motion.
Well, for something to be under tension, it has to have subunits. Which means that, yeah, I don't know. That's an interesting thing to ponder.
I think that there's no way to talk about energy without talking about, especially, there's no way to talk about why people have a hard time accepting material in motion as a definition for energy without talking about the larger framework in which this conversation about energy sits inside of. Because E equals mc squared is just one piece of the framework, because everything that comes after that is the like Big Bang black hole framework.
Yeah, for me, it's always been the case that the Big Bang proposals and Big Crunch and so forth, they suffer from so many inconsistencies with regard to their mechanism. It's so inchoate and so nebulous that it's much easier for me to just assume that the materials have always been there and there has been motion in the system always, and it's just being shuttled from one body to the next. Because I can imagine that. It's not difficult for me to imagine it. But all of these other proposals put the onus on the presenter to convince me of some mechanism that makes sense, and none of them have so far as I can see. You end up with the real problem of some external entity applying motion, because there's no way to imagine motion occurring without an external actor, right? Material in motion. It's going to have, you need another material to put it into motion that's already in motion, then you're just kicking the can down the line.
Well, if you have tension, there is the ability to get motion without an external actor, right? Because if you have a girdle around something, and the girdle...
You need a girdle breaker, though.
No, the girdle can break simply from the pressure on the interior.
But then why would it ever have tensioned up this way in the first place?
That's a good question, right? So it's like
They just all beg for external actors. That's the problem that I run into. And I also just, the alternative is just so simple and easy. And I think a lot of people think that eternity is incomprehensible, but I've never had that problem. It just makes perfect sense to me.
It's not that it's incomprehensible, it's that it does not make sense that there isn't something outside of the system. There's no such thing.
The system is defined by being totalizing. Like, the word universe literally means everything.
Right?
So it's
well,
not a
no, it's
galaxy.
everything that you can see and interact
To
with.
astronomers it is. But I think, like, to philosophers, the universe, by definition, means everything.
Yes, but that's not a scientific, that's a philosophical definition is not a scientific one. And so if we're talking about science, then we have to talk about the fact of, like, it is the sum total of things that we have access to. And I think that people are open to the idea that, like, hey, there might be stuff that lies outside of what we can interact with. Like, this is Don Hoffman's thing. There's something outside of space-time that shapes space-time. What is space-time? Space-time is the sum total of all things that we can see and manipulate. But there's something outside of it that can act as the prime mover. And I think that that's why he is pursuing this so doggedly, because he believes that there is something that can be attributed to causing the motion.
Yeah, thoughts. I mean, thoughts are outside of space-time. By that framework, they're certainly far removed in orders of abstraction from just material in motion. And if space-time is just a coordinate landscape for gauging the motion of materials, which it seems to be, then yeah, certainly there's quite a bit going on beyond. But it's still relational. It's just abstracted relationships to other relationships to other relationships that finally terminate in materials in motion. But there's so many orders of abstraction at that far removed distance that.
What do you get by saying that energy is material in motion? Like, what does that allow you to do?
Well, in so much as I'm working on the project of giving the atom material representation, it allows me to understand that the energetics can tell me about the materials of the atom and how they're moving. And I think it's just, as a physicist, your job should always be to explain how the materials are moving to affect the phenomenon. That might not be the case for a psychologist or mythologist, an archaeologist, a biologist even. You might not really be concerned with those questions, but I don't think that this project would exist if we didn't agree that that is, in some sense, the primary responsibility of the physicist, to give us physical, i.e. material, pictures of what is happening, to give us explanations that involve materials acting out and giving us the mysterious phenomena of light and magnetism without just kicking it down the can to some nebulous entity they call energy. And actually, looking at it in terms of energy is great once you understand that, hey, I'm just talking about some materials doing something, and this is how fast they're doing it, how frenetically, how slowly, how fast, what are the rates of change, you know? So it can be a quite useful concept.
And it makes a lot of sense to me because of this project where it's possible to plant a flag that you can orient yourself around. And I think that that's one of the hardest things in any physical conversation is to be able to say, okay, well, what are the fundamental things that we can take as the most basic laws that then allow us to construct everything else? And energy is obviously a massively important component of any physical explanation because, like you said, when it comes down to it, what we're really talking about is the fact that energy is fundamental. Like it is the thing that allows you to do other things. It is the idea that allows you to do other things. And so it makes a lot of sense for this setting. And personally, I think that the reason that people are unsatisfied with that is because it leaves them with more questions than answers about the nature of energy. But that could be incomplete. And so I wonder if you guys who are watching can drop in the comments what you think about this definition of energy and if it leaves you unsatisfied, and if it does leave you unsatisfied, why? Because we need to be able to, for the book, figure out how to talk about this in a way that addresses people's concerns.
I like that. All right, guys, let us know what other mysteries of the atomic world you want us to address. I know we haven't made a video on magnetism yet, now that we have this updated model of electricity and light and so forth, so we might get to that. We're going to hopefully be working with our animator to get some really cool movies to go along with this book as well. And anyways, tell us what you think. We'll see you guys next time.